Welcome to Chapter 9, Section 3, Altitude-on-Hypotenuse Theorems. In this section, we're going to identify the relationships between the parts of a right triangle when an altitude is drawn to the hypotenuse. So we're going to take a look at a diagram that you've seen before, and actually we've seen it in previous chapters, in that we have a right triangle, and from the right angle, we draw an altitude to the hypotenuse. And remember, an altitude is going to be perpendicular, so it's going to form a right angle at the hypotenuse. In this case, our hypotenuse is AB. And what we have here, our result, is three right triangles. And we're going to take a look at these right triangles and see what we know. Well, first off, if we look at this little right triangle, the smallest of the three, and the biggest right triangle, we know that they share a side AC, but that's not as important as the fact that they share an angle at A. So we know this angle is congruent to this angle. Well, those two angles are congruent because A is reflexive, and we also know that the angle at D in the small triangle and the angle at C in the big triangle are congruent because they're both right angles. And so if we have two angles that are congruent, we can say that these two triangles are similar. But what's more important than the fact that they're similar is the relationship that comes about by setting up the similarity. So if we look at, well, what sides are proportional, we can see that AB over AC is equal to AC over AD. Now let's take a look at that and see that that makes sense. AB, the hypotenuse of the big one, over AC, the hypotenuse of the small one. Okay, the hypotenusi correspond to each other. And then AC, the short leg of the big one, and AD, the short leg of the small one. All right, well, if you look, AC, well, those are the means of our proportion here, and they're the same. So if we cross multiply here, we see that the quantity of AC squared is equal to the product of AB and AD. Okay, so that's kind of significant. We're going to get to a formula that's going to help us a little later, but right here it shows that AC squared is equal to the product of AB and AD. So just to find this side that these two triangles have in common, that squared is equal to the product of AD times the entire hypotenuse AB. Okay, let's look at another triangle pair. All right, let's look at that medium right triangle. And still the big right triangle. They both have a right angle. This one's at D and that one's at C. And they also have a reflexive angle at B. So once again, we can say these two triangles are similar because of the AA theorem. Now, when we compare the proportional sides here, we see that AB over CB is equal to CB over DB. Now, once again, let's take a look at that. AB, so we're talking about AB, the hypotenuse, all right, is going to be over the hypotenuse of the medium triangle. So that's CB. So those correspond. And then CB on the big triangle is the longer leg, and the longer leg of the big triangle is DB. All right. So once again, what do we notice? The means are the same, so when we cross multiply, we get CB squared. So this side length, CB squared, is equal to DB times AB. And it's a very similar result as what we got on the last slide. All right, and what we're seeing here is we're seeing that the leg of the triangle, that leg squared, is equal to the transposed leg onto the hypotenuse times the hypotenuse. Now I'll explain what that means more later, but if you look, this leg transposed onto the hypotenuse is DB, okay? And this leg AC transposed onto the hypotenuse is AD. And so to find either of these legs, we just take that quantity squared is equal to the transposed piece times the entire piece of the hypotenuse. All right, let's look at one last triangle pair. If we look at the small and the medium. Now, we don't have any reflexive angles here, but we do know that this triangle is similar to that triangle. Well, why can we say that? Well, we know that the big triangle, the big right triangle, was similar to the small right triangle, and the big right triangle was similar to the medium right triangle. So therefore, we can conclude that the small right triangle has to be similar to the medium right triangle. What property tells us? Well, that's the transitive property. The transitive property tells us that the small and medium have to be similar. So if they're similar, well, what can we set up? Well, we can say that AD over CD is equal to CD over DB. Now, once again, let's make sure that this makes sense. AD in the small triangle is the small leg over CD, the medium triangle, small leg, is equal to CD, the bigger leg in the small triangle, over the bigger leg, DB, in the medium triangle. All right, well, once again, our means are the same. So we find that CD squared is equal to the product of AD times DB. Now, we've got a lot of segments here, a lot of things going on, products, squares, all that stuff. Well, what I did here is basically I gave you the proof before giving you the theorem of Theorem 68, all right, where it states that if an altitude is drawn to the hypotenuse of a right triangle, then we have these three conditions that are always going to be true, A, B, and C here. So we've got a diagram here that shows triangle ABC is a big right triangle. We draw a hypotenuse from angle C, the right angle, or we draw an altitude, excuse me, from the right angle to the hypotenuse at point D, and we label our legs A and B. Little a, little b, those are our legs. And our hypotenuse we call C. Okay, now why do we call them that? Well, little a is opposite angle A. Little b is opposite angle B. Little c is opposite angle C. So that's why we call the legs A and B and the hypotenuse C. Well, we also bring in two other pieces on our hypotenuse because our hypotenuse is split up into AD and DB. So we're going to call that segment ADX. We're going to call this segment Y. And then we're going to call the altitude H. Why do we use the letter H? Well, that tells us the height of that triangle with the hypotenuse as the base. All right, so given all of these parameters and all those variables there, we can talk about these three conditions that are always true when we draw an altitude to the hypotenuse of a right triangle. First off, the three triangles are similar, and we just went through convincing ourselves of that the last few moments. We know that the altitude is the mean proportional between the segments of the hypotenuse. Well, that was what we did on the last slide. Now, we didn't see it quite like that. We saw it like this. CD is equal to the product of AD and DB. This is just a shorter version. H squared is equal to XY. All right, and it's a lot neater. It's a lot easier to work with. So we see the altitude H is equal to, well, the altitude squared is equal to the product of the two segments on the hypotenuse. And then finally, either leg is defined as A squared equals YC and B squared equals XC. These are very, very important. We are going to use these a lot, and you need to know these formulas. Now, once again, talked about how does this make sense or a way to remember it. Well, A squared is just going to equal its transposed version on the hypotenuse, so this transposed on the hypotenuse is y, and then take that times the entire hypotenuse, c. Same thing with b. b squared is equal to its transposed segment on the hypotenuse, or the adjacent segment on the hypotenuse, if you want to remember it that way, times the entire hypotenuse, c. All right, let's try a practice problem with this. So let's say we have the same diagram. We have a right triangle, and an altitude is drawn from the right angle to the hypotenuse. All right, and we have the leg of the triangle here is 10. This leg, we don't know what it is. We want to find x, and we know that part of our hypotenuse, db, is 21. Now, if you want to label this, which it would be helpful to label this just like we did on the last slide. So label all the same variables like we have here. Let's label them on this diagram. So this side is opposite angle B, so we call that segment B. And this side is opposite angle A, so we call that segment A. The altitude here is the height of the triangle, so we call it H. This is called Y, and this is called X because it's already labeled X. All right? So we want to find x. Well, what do we know given our information? We know that this squared, b squared, is equal to x times c. So b squared is equal to x times c, and we saw that over here. B squared is equal to x times c. So we know b, so b squared is, well, b is 10, so b squared is 100. And we don't know what x is, so we're just going to leave x there. And we ask ourselves, well, what's c? c is not 21 here. c is this entire segment, the hypotenuse. And so in this case, c is the quantity of x plus 21. All right, that's important there. We need to recognize that c is the entire hypotenuse, the quantity x plus 21. Well, at this point, our geometry is done, and it just becomes an algebra problem. So in order to solve this, it's a quadratic, so we have to distribute, and we get x squared plus 21x minus 100 equals 0. All right, so we have to solve this. Many different methods we can use to solve it. You can use completing the square, you can use quadratic formula, or you can factor. This one can be factored, and so if we look at x squared plus 21x minus 100 equal to 0, we can factor this into x plus 25 and x minus 4. Okay, because 4 times 25 is 100, and 25 minus 4 is 21. Well, what does that give us? That gives us an x value of negative 25 and an x value of 4. Now, x in this situation can equal two different numbers, so we have to look and see, well, which one makes sense? Well, we can't have a negative distance here between a and d, and the segment length can't be negative, so we're going to throw that one out, and 4 is the only one that makes sense. So in class, we are going to practice some more of this tomorrow. If you want to take a look at the section 9.3 in the book and work a few practice problems, you can. Otherwise, be ready to do this stuff in class tomorrow.